Hello, everyone. Thank you for joining this week's Tips and Tricks webinar. Today's topic is going to be on checkpoint DNS security. So please use the Q&A chat if you have any questions. We'll make sure we get to those during the webinar. Our presenter today is a security engineer from North Carolina, Andy Thomas. Andy, what do you have for us today?
Hey, Rob. Thanks. Good morning, everyone. I just wanted to welcome you and hopefully have a good time talking about DNS and how to secure it with Checkpoint. As we know, DNS has been around a while, a little bit dated as a protocol, and we'll get into that a little bit, but it's become something very useful to hackers to abuse. And we obviously see that, and it's a key part of our prevention strategy. So we'll just jump right in. We'll talk about basically DNS in a nutshell, just the protocol. We'll talk about one of the key components of that protection is Checkpoint's DNS Malware Trap and the purpose of it. Talk about IPS DNS protections briefly, some of the advanced DNS attacks that we're dealing with these days, and then kind of what our advanced DNS security solution is in R8020 specifically, and then we'll wrap up and do some questions. So DNS in a nutshell, dated protocol, been around. I mean, it's kind of part of the foundation of the internet. And even though it's been updated to support IPv6 and stuff, it's pretty much the same protocol. There's been some additions on how people use it. Used to, it was pretty simple, but now there's a lot of use of SRV records and whatnot. Things that can be used to protect mail and various other things, but essentially it gets down to it's basically the white pages or yellow pages for the internet. It gives you a domain name to IP address lookup. If you're on this call, everyone knows that, I'm sure. So, but we'll just talk a little bit more about it in depth. It's built in the 1980s, as I said, a little bit dated. It's hierarchical phone book, like I said, and it's pretty simple on the protocol and how it works. You got a client that goes to a DNS server that's doing the resolution or finding what that IP address is that matches the host name they put in the browser or whatever protocol or application they're using. It goes to the root server, which the root server will then tell it to top load the domain server, work it sits way back down to where you get the authoritative server for the domain, and it's actually what provides the query response to the client, and voila, you have your web page loads. Magic. Just a little bit about the hierarchy. I think everybody probably knows this. You have your root, then your top level domains, your second level domains, which is typically associated with the brand or the website. And then you get into subdomains that can branch off of that for other uses. Subdomains could be just a single host, or it could be a collection of hosts that you have up under that subdomain. In the protocol or in the packets, you have limitations on the size. These subdomains are considered labels, 63 bytes long. This is a lot of where the abuse happens, at least for DNS tunneling. You use actually domains to stuff in, and we'll get into that a little bit more, but you stuff in information in these subdomains. You use some translation or encoding to get it to where it's not obvious that it almost shows up as it's just whenever you do this application, it almost triggers that it is something that doesn't read like English, and sometimes that's easy to pick up, but not always. But that's what happens a lot of times in the abuse, is that the labels, these subdomains, are actually carrying the data that's being exfiltrated. So that ties into the DNS tunneling we'll talk about later. The total length is limited to 253 characters, but so you have to know that if you're a hacker of how much you have to work with to get your data out. DNS traps, kind of shifting gears. This is, I think I did this a while back, this diagram. but it's really good in just basically how DNS Trap works. The purpose of DNS Trap is to uniquely identify the infected client. And as we know, you've got this DNS resolver that's going out to the internet, and whenever the first call is made and Checkpoint sees that, or your gateway sees that, and it's got a bad reputation, it flags it immediately. There's poor DNS reputation, but all you see is the source as being the DNS server. You don't know what client's infected. What the purpose of the trap is to inject a bogus IP that you see on the screen there. You inject that bogus IP, and then any subsequent connections to that IP, which is a sinkhole or a honeypot that Checkpoint has. The default is, we'll talk about, it's 62.058.94, I believe. And we'll see it later. But basically, any connections to that from that client, we know that that client is infected because the Checkpoint gateway injected that bogus IP. That's the setting of the trap. Another thing that you can use Checkpoint to secure DNS is, of course, our IPS engine. Been around for some time. We have both protections for client and servers. Another thing that's new that some of the providers said, hey, let's secure these DNS queries that go out on the internet. Let's encapsulate them in an HTTPS or a TLS. Great idea, but it's just like HTTPS. Why do we have to put HTTPS inspection on all our gateways? So we can see not only good traffic, but malicious traffic, or at least distinguish the two. But if you don't have any insight into that, so really there's no good solution right now for inspecting this per se. The best thing to do right now, what we have available, is to block it. So you have to identify these, have these services identified on your gateway. You'll notice that it's built into like Firefox, Chrome, iOS, Android, Mac OS. I'll show you a rule that how we use just a simple block rule to prevent that from happening later. Just DNS information for the DNS lookup over HTTPS or TLS. You know, that's not a simple DNS query. If you've ever seen a Wireshark packet, of course, this isn't Wireshark, but this is what it looks from curl, what it would look like. And again, another thing, DNS, this is not DNSSEC to distinguish it, DNS over TLS. It's another way other than the HTTPS method of querying. You know, the DNS over TLS is how it works, is it's over port 853. We don't have a service defined for that. You would have to define a customer, but you can block it similarly to DNS over HTTP. I mentioned DNSSEC briefly there. That is something more to prevent cache poisoning and more of a server-based protection. So just how it's become pervasive, 80% of organizations experienced DNS attacks in 2020. That says it all. And the average cost of the attack, almost $1 million. So it's prevalent, and it's something that needs, you know, obviously needs to be addressed. So, you know, DNS, like HTTP and HTTPS, they're open ways that we have to interact with the internet and anybody on that internet. So it's something that we have to open up access to, and therefore the hackers abuse that. But it is outdated, doesn't really have any security measures built in, other than, say, like DNSSEC. But from a client perspective, to keep prevention of DNS tunneling or domain generation algorithm kind of stuff, there's really not any protections built in to prevent that. You know, DNS is used, like I said, for C2 communication, which is another can or may or may not be a tunneling use, but definitely DNS can be used for C2 communication to get data back to the attacker. So how are we harvesting all this information? There's a lot of these DNS engines that you'll see that they're in the threat cloud. We're analyzing customer traffic. And through that, we're able to take and all that stuff we learned from the analysis, deep learning engines, zero phishing engines, and we pump that back into our reputation database. So it's a wheel, it's progressive, and it's constantly building on what how the attacks and campaigns are working. This is just some highlights of all the stuff related to where we're doing DNS protections, all these AI engines, static analysis engines, all the ones in blue, I believe, or in bold actually are actually DNS type of protection. So we got all these engines that it takes to secure your network, and just know that we're constantly looking at improved ways using AI, machine learning, standard methods, sandboxing, and all that to glean all this information. As I mentioned, domain generation algorithm on the far right there, you see these, it's where you're using all these domains to bypass. They're constantly being generated. The more they're generated, all the detection engines, all the known type of detections are hard. It's hard to keep up because they're constantly generating these domains, and it's a big part of the attack surface these days. And then you have DNS tunneling, which mentioned that a little bit, of ways of getting data out of using DNS packets through query to get basically data out, and it's obfuscated, so it's not obvious to the client what's going on. So we have a deep learning engines for that as well to detect that. Not to get into it too much, but this is just kind of the flow of how we would use, say, an emulation environment to find detect DGAs. More than 650,000 new domains per day. That just tells you when machines generate DNS, they do it much faster than humans. More on the DGA algorithm, DNS security operation, obviously IPS signatures, we mentioned that. Antibot's a big part of DNS security, along with URL filtering, and pretty much that will evolve in R82. I'm not going to say a lot about that, but that will evolve. It is included with NGTP and NGTX. Here's some resources on Malware Trap, Malware Trap protection in R81, the DOH, kind of how that works, an SK article on that, and then Threat Cloud, domain DGA protection and DNS tunneling specific articles on that. So we cannot inspect DNS over HTTP, which I mentioned. You can block it, and same thing with DNS over TLS. HTTP inspection is important to be able to even do the DNS over HTTP. Obviously, we want our customers running HTTPS inspection. So here's a couple of queries that you can run to find these new advanced preventions that we've provided for DNS tunneling and DGA, and we'll do a little bit in the lab to show that. And so we're through, and so we're going to switch over to the demo now. I have to use another machine. Let me do that quick switch. Stop sharing. All right.
Yep, we got you.
Okay. 1 second. Let me get my script up. All right. So the first thing I want to go over is DNS Malware Trap. To configure it, in my policy, security policy and my threat prevention. I'm using autonomous. So on autonomous settings, like, well, I'm going to go into the custom first to see let you see what's available on DNS Trap. If you've never been here, just some guidance on this. DNS Trap, you want to define your internal DNS servers. So when lookups come, you can distinguish them from the client. You also have this activate. That's all you have to do to activate the DNS Trap. You can do your own custom IP, but some important notes here. Don't use a loopback, because that is just sinkhole it to your workstation. It never goes through the network. You never can inject a trap. You also want it to be you don't want it to be an internal DNS server that never would make a call outside, or you wouldn't necessarily see the traffic. Maybe even if it's internal and it would be cached, you may never see the lookup to the internet. You want it to be something that's like a DNS server that's maybe in your DMZ. I recommend just leaving it alone. There's a checkpoint address that we'll see in the logs that will identify what that IP address is. It's in the SK article, but it'll give you guidance on, it'll just give you guidance on what clients are infected. Again, it's that subsequent connection after the DNS lookup that exposes the client of trying to make malicious traffic after the lookup and with the bogus IP. So this is not necessarily exposed on autonomous. We take the default, our default here, and there is and I don't have the link to it, but there is a way to actually do this through command line to put your DNS servers in. I believe that's a command line thing that we have to do. There probably in the future in autonomous, there'll be ways to define this, but typically that's where people go. If I'm switched over to autonomous, how do I configure this section? So we're going to show you a little bit of what that looks like. I did some pre-canned queries, and I'm not going to, for time's sake, I did one that we know is kind of a test tunneling site here. You'll notice that whenever you look at it, this is the IP address. This is the checkpoint IP address for the DNS Malware Trap. And then that tunnel, that works for the DNS tunneling. We inject the same bogus IP for that when we detect that. But in just a general DNS reputation, I use this OpenFish URL. Some people ask about that. It's important to be careful with this. DNS lookups are not going to harm anything really, just to do a DNS lookup. And then to test it, you can do instead of opening a web page and having all the payload come down, you can just do like a telnet or a telnet to 443, and that'll simulate the traffic and cause a trap. So that's what I'm going to show you in the logs now. When you go over there, these are the ones that I pre-did, but you'll get a feel for it. You'll see the host. You'll see the protection name here. So this is the one where, well, let's do the phishing one first, the first DNS trap that I did. You'll see that the query was done. So this is the DNS traffic and the DNS reputation. So you know that there's something going on in your network, but all you see is the DNS server. So when you go up here, this is where you'll notice it's on, let's see, it's on telnet. I just did a simple telnet to this host name, test dot whatever. And that's what triggered. And so that's how malware trap works. So you're going to have two connections for usually any DNS trap event. You're going to have the initial lookup for the reputation and then the trap of the subsequent follow-up connection to that. So while we're here, I might as well just go ahead and handle this now. I also did this simulated traffic, and you see the DNS tunnel protection name. And so I did here the connection to the greattunnel.com. You can test this. I believe this is kind of like ICAR. It's not truly not truly a malicious site, but you see it detect, because that's just the DNS lookup. but any future, all I did was DNS lookup. I didn't do any subsequent tunneling attempt. That would be through actually an application that's actually trying to get the data out. But again, you see this, it's triggered, and you could use a query. I just use this simple query. You could use that query that I mentioned earlier in the presentation about querying for the tunnel. There's also a query for the DGA. So moving on to security policies and IPS protections. If you want to look at anything related to DNS, you can do a filter for DNS. There's a couple different ways to do this to get more granular on your filter. But here, I like searching at product level best. There we go. I'm not patient enough and click too much. Do this again. And you see, you have all these different. So if you want client, server, you can select each one of those and it'll bring a filter up for each one of them that you check. Takes a little bit, but you see all these are related to DNS. Easy enough to find those type of protections. All right, so back to DNS over HTTPS. If you go into security policies, and I have this, this is an access control policy. This is just a simple rule that you would use to block that DNS over HTTPS. Now, on this DOH, you got DNS Crypt2. I didn't really mention that. That's another form of, encrypting DNS traffic. But on this application, there's an SK article. There's something that you may have to do as you've done upgrades. This, when you go in and search applications, you may not find this. I didn't initially. There's an SK article that I believe it is referenced in the presentation that just defines what you need to do to get this to be exposed. But again, you could also add the one that DNS over TLS. It's the port 843. You could add. I haven't added that in yet, but as you can see, this is one where I actually, let's see if this works now. So initially when I did that, you'll notice that it didn't load. I had already tried this. I had a block on and it didn't load. I need to do a little bit more testing with this. There's a question out there that what would the performance be like if we're blocking DNS over HTTP? And I need to play with it a little bit. You know that people do block that, and it's not always going to be available. So people that built the browsers, they had to accommodate that. My guess is the timeouts are pretty quick. If DNS over HTTPS is not available and it is enabled on the browser, it should fall through and do standard DNS resolution on the client. Just something to be aware of. This is something that you want to test in your lab before you go out there and just start blocking DNS over HTTP. So I think, Rob, we're probably getting close on time. That's the extent of the lab. Do we have any questions, or how are we doing on time?
No, we're doing perfect here, Andy.
Okay.
We do have some questions for you.
Okay.
Well, the one you just kind of answered there, does blocking DNS over HTTPS or DNS over TLS affect browsing performance?
Yeah, as I said, I would expect it may be some. Again, that's something that you're going to try out in your environment. But I have to think that the browser, whoever put this into the browsers accounts for that, and the fallback again would be to DNS to where it wouldn't be totally blocking, it would just be blocking the encryption of the DNS traffic, not DNS.
Are the settings configurable when using the autonomous policy in threat prevention?
So back on that, we kind of touched on that a little bit. It's not, whenever you go into autonomous, this is all you get. You really don't get a lot to configure. What you see on custom, you don't get that. The default though is, as I said, and again, I'll show in the logs. Well, in the logs, it's a 62.058.94 that you would see for the sinkhole or honeypot. The checkpoint address, you don't really have a way to override that. I've heard they're going to change that, and that'll be available in R82, I believe it is. As far as your DNS server settings, that's available to change that through a command line, and I don't have that available. But that's what I've been told.
Okay. And there's a kind of a long one, but I'll try and read it. Does Checkpoint provide any means to test DNS security when enabled in the firewall? Like a link to host when looked up will cause a trap response, or anything to test exfiltration being blocked?
So, good question. I try to use sometimes reputations, external threat feeds and stuff like that, things that customers don't have the full Checkpoint database exposed to them directly. They usually it's based on reaction of what they see in their logs. One thing that I've always found to be pretty good is OpenFish. Again, this comes with a caveat, use at your own risk. But if you use it like I did, where we went in here and did simple lookups, you can't really be affected by that. Just do a lookup of the OpenFish. That's where I got this from OpenFish. And then you do a telnet to it, which isn't really going to, you don't even have to use a standard protocol call like 80 or 443. You can just telnet it. It'll trigger the trap. So in that case, yeah, I think that the OpenFish with just NS lookup and telnet to the host name will be sufficient.
Okay. I think that covered it on questions in case unless anybody wants to throw one in there, but you did answer a few during the prezo. So thank you, Andy. Great information as always. We'll send the follow-up email with any referenced content and the recording link. You'll be seeing that soon. And our next webinar will be in 2 weeks. You'll see the invitation for that soon also. So thank you again for joining. We'll see you here next time. Enjoy your day. Thank you, Andy.
Thanks, Rob. Thanks, everyone. Have a good day.
Bye now.